Now these examples, starting from number 4 and beyond, we need to pay more attention because now, remember those videos I showed you how to use the union and the intersection of the two intervals. Here's how we can actually start using them. So the type of compound inequality right here that we're going to solve, they are the two separate ones, but they are being joined by a union, or the keyword or. Now, by the way, the title for the example is solve and graph. And the inequality here I have is 4x minus 3 less than negative 19, or 2x minus 1 greater than negative 11. So now, pay a little more attention here. Now, what I see is, in this problem, things don't go simple like, things don't go like the case of those compound inequalities where you have the 3 sides anymore. Things don't go like that anymore. Here we really have 2 independent inequalities to solve for. And then the 2 inequalities here, they are connected by the keyword or. And that keyword right here, thinking in terms of the set theory, thinking in terms of set notations, it's the or right here is the same as the union sign. Okay, and we're going to go more in detail about that. But now, for now, let's just pretend like you're going to solve these 2 inequalities right here independently from each other. So the first one here, and keep in mind the keyword or coming along every single step as you proceed to solve these 2 independent inequalities. So now, the left one, adding 3, that gets me 4x less than negative 16, and then you divide both sides by 4, and my final answer for that, x less than negative 4. Okay? And you don't need to change the inequality at all. Now, for the other side here, when you're solving for that, adding 1 to both sides, that gets you 2x greater than negative 10, and dividing both sides by 2, that gets you x greater than negative 5. And once again, you did not have to change the direction of the inequality. Now, keep in mind every single step that you solve, or, and finally, or. What that means is the solutions is x less than negative 4 or x greater than negative 5. So the point now is that as long as the x values satisfy one of these 2 conditions right here, then it will satisfy one of the inequalities that we started out. And that's what the or is about. The or here strictly does not mean the either or, the exclusive or. Okay? It's just the inclusive or. It can be either one. It can be one of the 2 conditions here, or both. Now, there's a danger point here that try not to do. Okay, there are a lot of students of mine that have been doing this. Now, a lot of students of mine have been trying to combine all this here into like one inequality like this. Okay, so please don't do this. Even though in this particular problem, it is okay to see things like this. However, the problem here is that later on, if you keep doing this, it's gonna run into some serious logical error. So once again, what I'm trying to say here is, do not try to combine these 2 separate pieces of inequality into a 3 sides inequality like that. Okay, please just keep them as the way they appear, 2 separate ones. Okay, so now graphing the solutions of this. Now, on the first piece right here, the solution just for that one, or maybe the better way to explain this to you, is going to be actually, I think I do need to go back to a line here. But anyway, so negative 4 is here. How about negative 4 is here? Sorry. Negative 4 is here, and I need to shade to the left side of negative 4. Okay? I need to shade the left side of negative 4, and here's my parentheses. Okay? So that's how it gets for this. My other line, my other graph for that, for my other solutions. My graph, negative 5 is here. Of course, it's to the left-hand side of negative 4. And then you want to graph to the right-hand side because x greater than negative 5, and I want to use parentheses on that. And now, once again, but here are the two separate graphs of the two separate solutions. And we want to find the joint one. We want to find the combined version. So once again, think about when you superimpose the two lines together. When you superimpose the two lines together. Okay, when you bring the two lines and overlap them, I mean putting them one on one another, then we have something like this. Now, remember, the OR here, like I said, it's a union. So when you graph them, you think about, you don't find the intersection anymore. You don't try to find the overlapping. But when you superimpose these, you're just trying to count all wherever the regions reach. So in here, when you bring the two lines together, the regions reach all through. Right? The shaded regions all extend, the shading extends to all sides. So here, really, this is all my graph for the inequality. So that's why, like, if you look back into this, conventionally here, if anyone trying to bring the two separate inequalities here into something like this would be all wrong because the graph for this is simply in between negative 5 and negative 4, and you want things just in between only, which is really incorrect compared to the real version here. Alright, so once again, my bottom line here is you can always graph, okay, and you can always, and please always write the two answers here separate, just like that. Do not try to put them into one 3 sides inequality like this. It would be way wrong. Okay, and by the way, so completing the example here by putting all that in interval notation. So I have x, my one side here is x less than negative 4, so comma negative infinity, comma negative 4, parentheses. The other intervals here, that gives me another interval from negative 5 to positive infinity. So here I have negative 5 to positive infinity. And here I want to join these two by a union sign. And that's how I can express my solution in interval notation. Okay. So example number 5. Once again, another example where you can see the two independent inequalities again, and they are being connected by the OR word. So we want to solve a graph, and here I have 2x plus 7 less than negative 11, or negative 3x minus 2 greater than or equals to 13. And so now, once again, think about solving these two independently. I have 2x less than negative 18, dividing both sides by 2. And that gives me x less than negative 9. That's one of my solutions. Now, for the other inequality, the solution I need for that one, plus 2. And that gives me negative 3x greater than or equals to 13. And then dividing both sides, oops, sorry, wrong man. Positive 15. Sorry, I said negative 13. So negative 3x greater than or equals to positive 15, dividing both sides by negative 3 this time. And watch out, there's going to be some inequality change here. So we actually have x less than or equals to negative 5. Right? And so the final inequality here is indicating the solution that works for that system. A solution that works for that system is x less than negative 9 or x less than negative 5, less than or equals to negative 5, and that's make it work. So that's the logical equation. And once again, please do not try to bring all of this into a one 3 sides combined version of the inequality. That's way incorrect. To graph this, once again, between negative 9 and negative 5, negative 9 is the lower number, and negative 5 is the higher number. So here's how you put it in, -5, -9. Okay, and for -9, I want to shade to the left side of it, and I'm using parentheses on -9. For -5, I also want to shade to the left side of -5, and I want to use brackets on -5. And so now, when you think about getting a joint graph, when you combine this into coming into the overall graph, you need to think about superimpose all these, and just wherever far wherever the two shading together reaches, that's gonna be the final shading of your problems of your graph. So here's -5, and the two shade here, when you combine them together, it seems like that shading on the top line right here is included as part of the other shade. So really the overall graphing is going to be just all this. So this is the graph of the solution. So now, and the final inequality here is there's only one, when you really combine the two graphs, there's only one interval in the end. So it's really just -infinity to -5. All that. Okay. And then the last one, the last example. Once again, we want to solve and graph. And what I have here is 3x minus 2 greater than or equals -8, or 2x plus 1 less than or equals 9. So solving these two inequalities independently, what I need to do is, once again, plus 2 from both sides. That gets me 3x greater than or equals -6. And then dividing both sides by 3, x greater than or equals to -2. For this one here, I need to subtract 1 from both sides. And that gives me 2x less than or equals to 8. And dividing both sides by 2, I have x less than or equals to 4. Okay, so, and here, once again, keep in mind, here's the OR word. It's the OR word. So, and do not try to bring them, it would be wrong to bring them all together into something like this. X less than or equal to 4 and greater than or equal to -2. Okay? Now, this is going to be this is all wrong. You need to, if the inequality, so the bottom line here, if the inequalities, the system of inequalities start out with the OR in it, then make sure, please make sure that you're going to just simply keep the two solutions here separate and connect them by the OR word. Do not bring them into a combined version like this. So now, graphing the inequality. So once again, my top line right here is to represent the solution to the first one. And -2 is somewhere here. And I want x greater than or equals -2. So it's this part right here, shading to the right of -2 and brackets on -2. The second line is for that second solution. And 4, you can think about 4 is somewhere there. And of course, 4 appears to the right hand side of -2. And we're shading, we want x less than or equals less than or equals 4. So I'm shading all that here. And then I'm using brackets again on 4. And then so the overall graphing, so this time, the x value that works for any of these, that works for one of these inequalities, any x value that works for one of these equations, inequality is going to be all x value. Because think about it, once again, when you superimpose the two lines here together, then the shading together is going to reach to infinity. So that's all there is. It's going to reach to infinity. So here's your final graph of the solutions. And then thinking in terms of the final solutions in interval notation, it's going to be -infinity to +infinity. And that's how we finish graphing this inequality here using interval notations and finish graphing that.